The other thing I need to happen, I need this to kick over. And let me go ahead and share with you guys. Let me check the chat. Are they, wait. Kevin and KJ, are they in the other class or something? Or are they not able to get in, or what's the deal? Are they just not able to get in?
I think they're in now.
Oh, they are in?
Yeah.
Okay. Yeah, okay. I'm going to share the desktop. Share. We can minimize this and close this. I just need that to kick over. I'm just waiting for this to behave right, and then we're ready. Let me go like this. I think if I maybe like reboot this and suppose all this stuff out. Let's try this again. That's a good omen. All right, so we are here. Is this right? It should be this one. And let me change the title. This is supposed to be. This is correct. Let's just say continue. Oh, wrong one. Continue. All right. And so we're gonna so we're just gonna continue the study session. Let me make sure I'm streaming. So we're just gonna continue the study session where we left off from last time. It's not gonna be that long. We'll be here for maybe like right at about 30 or 40 minutes, like no more than 40 minutes. It'll be quick. Okay. So let me see. I need to do like. Let me see if that worked. That did work. Why was it not working yesterday? I don't know. Okay. Anyway, it doesn't matter. It's working now. Okay. So let's get our paper set up. Usually like grid paper, and I think the rest of this is fine. So we're asked to find. So this is kind of a repeat of number 17. It might be a little bit different. We're asked to find all rational zeros of the given polynomial, right? So this is number 18. It comes from section 2.3, question 41 from the back of that section. We're going to say we want to find, that's an F, find all rational zeros. Find all rational zeros. We have this, we have f of x equals x cubed minus x squared minus 37x minus 35. So normally I go extended periods of time without doing like dairy. I think I just had a wrap. It had like cheese and maybe ranch sauce in it. And that's when I was like, my body's trying to like get it out of my system immediately. It's like, hey, get that out of here. That's why I keep going like this, because I was fine like for a few days. And I just ate that cheese and now my body's like, no. I'm like, oh, that's right. I forgot about that. Okay, so let's hop over to the tablet. Let's see if that should be working there. That is displaying properly. Okay, so we want to find the zeros. Let me glance one more time just to make sure I wrote it down properly. X cubed minus x squared minus 37x. Because if we write it down incorrectly, we can waste a lot of time, right? Okay. So I think last time what we were doing, there were about 3 steps. There's still more steps that we could do. But we were doing the rational zero test denoted by P over Q, right? The P comes from the factors of the constant term. So the factors of negative 35 are going to be plus or minus 1. There's no 2, but we can do what? 3? No, we can't do 3. 35 is what? 7 times 5? So I think we only have 5, 7, and 35, right? Normally we would do divided by the factors of the leading coefficient, but the leading coefficient is 1, so everything divided by 1 is the list that you see here. Next thing that we did last time, we did a Descartes rule of signs. Descartes rule of signs. Okay, so if we evaluate f of x, we count the number of sign changes in f of x, that'll tell us the number of possible positive zeros. So we have one sign change there, and that's it. So this means that we have one possible positive zero. Okay? For the negative zeros, we evaluate f of negative x. So first I'm going to replace each x with a blank set of parentheses. Then inside the blank parentheses, we're going to put negative x. Okay? Then if we simplify, negative x cubed plus, nope, not plus. It's going to be minus x squared plus 37x minus 35. We got one sign change here and then a second sign change, right? So what this means is that we have either 2 or 0 possible negative zeros. Okay, let me see. Zeros, okay. Let's see. Let me see who that is. Give me a moment. It's kind of acting up a bit. Okay, I'm going to do it this way. Are you serious? All right, give me a moment, guys. It looks like it didn't say. Maybe this isn't the right one. Let me go back. Courses. This is with the lab. Where is it? Number 13. Not that one. With lab. Let's try this again. Maybe I'll click on the wrong thing. No. Ugh. I do not like this. It's not working right. Ugh. Oh. And trying to access this menu on the side is such a pain. Oh, you can't. I don't know. Yeah, it's totally acting up. Give me a moment, guys. Course tools, attendance. Okay. let me close this out because I know I'm going to have to. All right, let me admit. And I think you guys can see my screen. Did you lose our work too? No, okay. Just trying to think. Why can't you see screen? Let's try. Oh, was it recording? It's not supposed to be recording. Delete the movie. And then let's just do a new. Okay. I think we're back in action. I just needed to convert over. Ho, ho, ho. Yeah, I'm just trying to get it to kick over once it. There it is. Okay. All right. I think we're ready to go now. Okay. So where we left off, let me make sure I'm showing it here as well. Okay. So we did the cart rule of signs. From f of x, we got that there was one possible positive zero. And then when we did f of negative x, we had two sign changes. Yeah, so if we have two, that means we have either two or zero possible negative zeros, right? So whenever we have a number two or larger, we have to say that number, and then we have to keep decreasing it by two until we get to either zero or one. Okay. So for something to sense, just start with negative one, right? I'm just going to start with negative one. So I want to test to see if negative one is a zero. Let me see. So we need the coefficients. Let's see if we check our exponents. We have 3, 2, 1, 0. So the exponents are fine. So that means we don't need any placeholders. So the coefficients are 1, -1, -37, -35. Okay. So then if we do synthetic division, we get 1, -1, -2, 2, -35, 35. I don't know why something said check -1, but something did say it. I checked it. We found a 0. So at this stage, if we write out our factors, if -1 is a 0, that means x plus 1 is the factor. And since we started with a degree 3 polynomial, at this stage we have a degree 2 polynomial, right? So then that means we're going to have this times x squared minus 2x minus 35 equals 0. Okay? So then we want to see, can we factor that trinomial? Can we factor it into something like this? We have x and x. One has to be positive, one has to be negative. Two numbers that multiply to give us -35 and add to give us -2. I think it's -7 and +5. -7 and +5. Let's check really quickly. This times this is -35. This plus this is -2. Okay? So then our zeros end up being -1, -5, and 7. I don't know why I put that extra x in there. Extra x. Read all about it. Okay. We can check for the sake of time with all the little technical stuff that was going on. Let's just, I'm just going to put it into Pearson. So let's hop over to Pearson. Let me make sure it's showing. Okay. It's over there. Hey Siri, what time is it? Okay. -1, -5, and 7. -1, -5, and 7. All right, let me take the cat. Mm-hmm. I thought I could. Was that Google Halloween thing? I'm gonna check it out later. Okay. I think we're okay. All right, let's give this one a go because I don't think you can ever have too much practice finding zeros of a polynomial. So let's do number 19. This comes from section 2.3, number 43. Find all rational zeros. We have g of x equals 21x cubed plus 67x squared plus 11x minus 3. Okay, let's do the rational zero test. So then the P over Q, even though these all look the same, oh, you guys got to be able to see it. So let's hop this way. Let's go like this, and let's make sure it's showing. Okay. So you got your space heater, so you good now? Okay. So P comes from the factors of the constant term. So the factors of 3 are just plus or minus 1 and plus or minus 3. The factors of the leading coefficient, we got 21. So those factors are going to be plus or minus 1. If we got plus or minus 3, 21 is what? 7 times 3? Okay. So then it looks like all that's left is 7 and 21, right? So what we need to do all combinations with everything on top divided by each thing on bottom, right? Okay. So then the list we generate, if we do everything on top divided by 1, we get this. If we divide by 3, the only thing that's new is the 1/3, because 3 divided by 3 is 1, and we don't write it a second time. If we do everything divided by 7, plus or minus 1/7, plus or minus 3/7. And then the last one, plus or minus 1/21, plus or minus 3/21. Do something really quickly. So I'm totally sleepy. I was trying something a little bit different today. Oftentimes I find myself having to decide, okay, do I want to do like some Uber Eats, like some deliveries, or do I want to go exercise? And like where I need to exercise, I often find myself doing Uber Eats. And so I was like, okay. I met this guy last weekend. He was like, I was like, are you doing food delivery on a bike? He was like, yeah. I was like, what platform? He said Uber Eats. I was like, oh, I didn't know you could do that. So I just went on to sign up for Uber Eats on a bicycle. So that's why I'm like so drained. Like it was okay. I was definitely getting sweat. I was sweating and I was still generating money. So I was happy about that. Getting paid to work out. I found another way to get paid to do what I love to do, even if it's on a small scale, because it can start like that, then it'll grow. Right? It can grow into something bigger. Um, but yeah, that feeling of getting paid to do what you want to do, like I really enjoyed that. Okay, so we have this list of possible rational zeros. It's a pretty extensive list. Let's do the cart rule of signs again really quickly. So if we count, let's look at g of x first. 21x cubed, 67x squared, 11x minus 3. I think we only have one sign change. So that means we have one possible positive 0. Okay. Then let's do it. Let's evaluate g of negative x. So first I replace my x's with a blank parentheses and create space. 21x cubed plus 67x squared plus 11x minus 3. Notice with all these examples, I'm essentially doing this. Oh, that's not right. I'm essentially doing the same thing every time, and then just adjusting or catching the changes as they arise. Okay. 3, 2, 1, 0. Okay. Let's see. The first one is going to be negative 21x cubed. That's going to be positive 67x squared, negative 11x minus 3, right? So the number of sign changes, there's one here, one here. So there are two sign changes. So that means we have either 2 or 0 possible negative zeros. Okay. Let's see. Okay, I think this time I'm going to start with 1. Let's see what happens. So if we put 1 in a chair, I don't think we need any placeholders. 3, 2, 1, 0. So then the coefficients are 21, 67, 11, negative 3, right? Let's see what happens. 21, 21, 88, 88, 99, 99, I think we get 96. So that's not a 0. Let's try negative 1. 21, 67, 11, negative 3. This comes down. What is that? 6, 46? Negative 46. This doesn't look promising either. 6 minus 1 is 5. 3. We get 35 minus 3 is 32. So that's not a 0. Okay, let's go back. So notice that when we did 1, that last column was either entirely positive or 0. So that means that 1 is an upper bound. So when we have a positive number in the chair, and that final row is entirely positive or 0, that means that that's an upper bound. So that means that the 0 is not going to be above this number, right? So if we have a positive number larger than 1, we don't have to check it. And I think there's only one number larger than 1, which is 3. So I'm going to just put an X above the 3 to signify we're not going to take the positive 3, but it has to be smaller than 1 if there is one. Okay, so negative 1 didn't work. Something saying, well, we know we can't do 3. Let me see if there's a lower bound. Nope. So let me try negative 3. I think I'm going to try a third instead. Let me see. I'm going to do negative 1/3. I'm just filling it out. I'm just guessing. Negative 1/3, right? So then if we do this, 67, 11, and negative 3. 21 comes down. What is that, a negative 7? Then that's going to be 60. That's going to be a negative 20. That's going to be negative 9. Is 3. And we found a 0. All right, so we found it, right? I totally just was like trying to fill it out. I just guessed. Okay. Let's see. So we started with the degree 3. So at this stage, we're at the degree 2. So we have 21x squared plus 60x minus 9. Okay. And let's write out our factors. So if negative 1/3 is a factor, that means that x plus 1/3, sorry, if negative negative 1/3 is a 0, that means x plus 1/3 is a factor. And we can multiply that by 21x squared plus 60x minus 9 equals 0. It looks like all of those are at least divisible by 3. Let's factor out a 3 from the first one, and I'm probably just going to multiply the first one by 3. Sorry, let's factor out a 3 from the second one, and we can probably pass that 3 through the first one. Okay? So if we move the 3 from the second one to the first one, we're going to get 3x plus 1. If we remove the 3 from there, that becomes 7x squared plus 20x minus 3. Okay? So now, I think we can factor it the following way. 3x plus 1. And we can just kind of jump straight to we might be able to jump straight to this form, right? So let me see. We're looking for two numbers that multiply to give us negative 21 and add to give us 20. One and 21. Negative 1 and positive 21. Nope. Yeah. All right. Let's see. So what I'm gonna do, I'm gonna rewrite. Let me see. This blue 20 using one. Let me see. 21 and negative 1, right? So the 7x comes down. So the two numbers that we found were positive 21x minus x. They multiply to give us 21 and they add to give us 20. The negative 3 comes down. And so now we're ready for factor by grouping. You also may have seen me do this step called the box method, right? Okay. So now if we do factor by grouping, the first two, we ask ourselves, what do the first two have in common? Well, the first two both have a 7x that can be factored out. So this 3x plus 1 comes down. We have a 7x, and we're going to be left with x plus 3. The hint is we're looking for another x plus 3 on the right-hand side. Okay, so what can we factor out of the second two in order to get that blue x plus 3? They both have negative 1. So now both terms have a common binomial factor, so we're going to factor out this blue thing from both terms. We're going to have 3x plus 1. We're going to have, we have 3x plus 1. We have this x plus 3. And we have this 7x minus 1. So then we see that the zeros, we get a negative 1/3, negative 3, and 1 by 7. Okay. So just for the sake of time, I'm not going to check it. Normally I would type the original into my calculator and then pass these through that function to make sure that they produce zeros. I'm just going to hop back over to Pearson. Just hop over to Pearson and put those results in. All the zeros use commas. We should have 3 or no more than 3. Negative, that's not a negative. Negative 1 by 3. Comma, negative 3, comma, 1 by 7. See that fine? Okay. Hit enter. Okay. Let's do one more good one and then we'll call it a day. This one looks good. Yeah, let's just do it. Okay. It's broken. And not the device. Awesome sauce. That's all I need. So we're doing number 20. Let's start here. So then question number 20. Oh, yeah. This comes from 2-3, number 45, section 45. Find all rational zeros. Find all rational zeros. Okay. We have h of x equals x to the 4 minus 2x cubed minus 34x squared minus 67x minus 30. Okay. These polynomials are getting longer and longer. Okay, so fortunately our leading coefficient is a 1, so that makes the rational zero test much easier. So we can say P over Q. The factors of 30, we have plus or minus 1. 30 is what, 3 times 10? So we have 2 plus or minus 2 plus or minus 3 plus or minus 5, and then I think it's what, 5 times 6, 3 times 10, 2 times 15, and 1 times 30. Okay. So these are all the factors of the constant term. Okay. Let's do the cart rule of signs test as quickly as we can. So then h of x, we got this x to the 4, 2x cubed, 34x squared, 67x, 30. Count the sign changes. 1, there's only one sign change. Okay. So that means we have one possible positive 0. Okay. Then the other side, we do h of negative x. So we do negative x to the 4, 2x cubed, 34x squared, 67x minus 30. I see the chat. Just give me a moment. I'm gonna trying to finish this out. So I can get you all out of here. Minus x, minus x, minus x, minus x, minus x. Okay, if we keep going, that's gonna become positive. That's gonna become positive 2x to the third. That's gonna stay negative. That's gonna be a positive 67x minus 30. Number of sign changes is 1, 2. Kind of looks like I think that's Amazon logo because it looks like a smiley arrow, smiley face. So what this means is that we have 2 possible, wait, not just 2. 2 or 0 possible negative zeros. Okay. Okay. Let me see. I feel inclined to start with 1, so let me see. Actually, do we have any fractions? We don't have any fractions. Okay. Yeah, let's just start with 1. That's the simple thing. So if we put 1 in the chair, let me see. If we check the exponents, 4, 3, 2, 1, 0. So the exponents are clear. Let's see. So we got 1, negative 2, negative 34, negative 67, negative 30. Okay, let's just see really quickly. 1, 1, negative 1, negative 1, negative 35. 90 plus 12 is 102, negative 102. See what it is, 72? I didn't do that right. I don't know why I'm subtracting. I know why I'm subtracting, but that's not right. We add those. It's going to be negative 132, but that's not a 0. And it's not entirely all positive, so it's not an upper bound. Let's just go ahead and do negative 1 since we're here. 1, negative 2, negative 34, negative 67, negative 30. So then we get our 1, negative 1, negative 3, 3, negative 31, 31. Oh, that was a 7. 7 minus 1 is 6, 36, negative, positive 36, the remainder is 6. Okay, I'm going to test another negative. because I like how the negative was kind of bringing them close. So I'm going to do -2 next. So -2. We got this 1, -2, -34, -67, -30. Right? I'm watching the clock. I know we're like at a mark. Let me see. 1, -2, -4, 8, -26, 54. So positive 54. Oh, no good. 3, 13. Close. Okay, just on faith, I'm going to try -3 because I feel like it needs to be negative. Negative, come on, 3. Okay. 1, -2, -34, -67, -30. 1, -3, -5, 15, 14 plus 5 is 19, so -19. 30 plus 27 is 57. Oh, 57. That's going to be what? -10. That's going to be 30. Okay, we found our 0. And we might have a little bit more work. Okay, so just to make sure, let's do the -3 again because it might have a multiplicity, even multiplicity, right? So if we do synthetic division again, just to make sure it doesn't occur more than once, we're going to bring this down. -3, -8, since 3 is 24. I think that's a 5. -15? No, that's not. It's not. So let me scrap this. Let me just delete it. Trying to finish this out. So since we started with the degree 4 polynomial, at this stage it's a degree 3. So we got x cubed, 5x squared, 5x minus 10. Okay. Let's write out our factors. X plus 3, x cubed minus 5x squared minus 19x minus 10 equals 0. Let's see. Should I do the next negative or should I go positive this time? -5. Let's try -5. So we'll do synthetic division with -5. We got 1, -5, -19, -10. 3, 2, 1, 0. 1, -5, that's going to be -10. That's going to be a positive 50. 31. No, that's not it, right? 155. -155. 165. Okay, so that's that remainder. What's the next one? 6. I'm going to try the 6. I think this is it. I'm confident in the 6. I'm going to do -6. All right, let's go for it. I'm getting you guys out of here. We still got a couple minutes. So we're here. 1, -5. Again, we could look at the graph on our calculator too. We always have that as an option. Okay. 1. It's gonna be -6, -11, 66. Oh, that's kind of a big jump. Okay. Let me start doing some of the positives. If there were 20, there would be 46, 47. 47. I'm just going to say no, right? Okay, let me try. What's the last positive? We know it wasn't 1. We try +2. Let's try +2. Oh, bound. Do we have any bounds? Alternating? Okay. It alternates there. It didn't alternate there. Okay. So it looks like we have a bound right here. All right. So we had a negative number in the chair and the signs alternate. Notice it goes positive, negative, positive, negative. If we ever have a 0 on that last row, it's a wild card. It can be whatever we need it to be. Right? So since we have a negative number in the chair and the signs alternate, that means that -5 serves as a bound, which means we don't have any zeros below -5. So any other negative, how many negatives we're anticipating? 2 or 0. There should be another negative 0 though. We tried -3 again. -5 was a bound. 1, -1, that's -3, 3, -31, 31, 36. Yeah. Trying to think. What else? Okay. It should be another -0. What's the time? Oh, I was trying not to look at the graph. Let me see. Let me see. Okay, let me start testing some of these positives. Let me test 2. Oops. I see the time. 1, -5, -19, -10. I might just let you guys go without finishing. 1, 2, -3, -6, -25. That's going to be what? -50. That's -60. Let me try 3. 1, -5, -19, -10. 1, 3, -2, -6, -25. That's my next class. And this is no good either. And I'm gonna try. We did 5 already. Oh, you know what? Did we test? Did we didn't. We never found another one. Let me try 5. 1, -5, -19, -10. 1, 5. Okay, we got a 0. That's interesting. 5 times 0 is 0. They add up to -19. That's still no good. All right. I'm going to let you guys go. I just didn't want to look at the graph. We could always look at the graph, see the zeros, and that'll tell us what to test. We found 1 0, but we never found another one. And I don't want to keep it any longer. So I'm just going to let that one be. But that's how they go sometimes, right? I would look at the graph at this stage. Unless we miss something somewhere. Yeah, I would just look at the graph. Okay, guys. But that's enough. But yeah, that's why I'm going to try them out. Because, sometimes that happens. Okay, have a good weekend. I'll see you guys. So next week, we'll probably go ahead. So exam 3 should be available on Wednesday. We will probably do section 3.1 next week. Okay? Enjoy your weekend. See you next time.
Yeah, Professor. Have a good weekend.